right, we are here so excited to talk about using AI agent to actually do something interesting. My name is Lin Sang. I'm the head of open source with the small company Solo.io. And Sara?
Hi, I'm Sara Qasmi. I'm a platform engineer working at Entity Data.
Awesome. By the way, we feel so special here because this is my first time speaking at Platform Engineering Day, and this is Sarah's first time doing any public speaking in any of the conference. So thank you.
Thank you.
Last year, Hurricane Helene hit southeast of United States really, really hard, and I live in North Carolina. I believe Atlanta was also hit pretty hard. And I remember that weekend when Hurricane Helene, sorry, is there a problem with the audio? Okay, thank you. And I believe during that weekend, many of my coworkers had to jump on a crisis to help our customer, which is an insurance company, to troubleshooting network issues because there were so many people filing claims and the production site was down. So we started to think about how can we leverage Agentic AI to do something useful for us when we don't want to do the job, like jump on a call on a weekend or maybe repeatedly explain something to somebody. And this is how we started this new project called kagent earlier this year to bring Agentic AI to cloud native. In fact, we have one of our lead maintainer, Eitan, right in here with us of the kagent project too. So in a nutshell, kagent is composed of three key components. One is the tools, MCP tools, which many of you are, how many of you are familiar with MCP tools? Awesome. How many of you actually use MCP tools? That's great. We also have agents. One thing agent that's really interesting to bring that Agentic AI experience to Kubernetes is the agents are declarative. So you can create agents like YAMLs. And then we have also the framework tier. We support Google's ADK, which is an open source agent execution framework. And you can also bring your own agent. And kagent has a UI to allow you to create agents as well. In a nutshell, I think all of you are actually pretty familiar with agent, given my sense of how many of you actually use MCP. The agent is composed of system prompt, which you provide instruction to your agent to tell your agent what to do. And the agent is also contains a configuration to connect to a large language model. And the agent is also contains what are the tools the agent needs to use. I'm not going to explain the model concept protocol. The way I'm always thinking about it is like a USB-C to my Mac machine or my laptop that allows me to connect all the fancy tools I need. And this is a simple diagram of agents running in kagent, and it could be outside of kagent. It's very, very generic agent concept where the agent is composed of system prompt, connection to large language model, and the tools. And the tools can be MCP tools for your GitHub, for your Docker, or for your Slack. And this is a fun story. So I was actually presenting, doing a live demo in Hong Kong, KubeCon, I think, in June. And Sarah was actually attending my talk. So during that keynote, I gave a live demo of using an agent I built to actually figure out, help me debugging an issue in my Kubernetes cluster, and having the agent actually submit a pull request on my behalf. And actually, the pull request contains a fix to the HTTP route to my cluster. So I was able to merge that pull request on stage and fix my environment. And Sarah and I got together and discussed, can we actually use this in her work? So we had some inspiration ideas, and I'm going to pass the microphone to Sarah for her to share her thoughts after she saw what I've done with kagent.
Thank you, Lynn. So, in GitOps modern environments, changes go straight from Git to Argo CD to the cluster. But semantic errors that requires understanding of the context aren't caught by the static validation tools. So a developer can merge a manifest that passes the YAML linting, the schema validation, but still breaks the cluster. And for example, missing dependencies like namespace quota violation, referencing an existent secret, etc. So GitOps gives us a single source of truth, but it does not tell us if this truth makes sense. We want to bring more intelligence and context awareness to our GitOps validation without breaking the developer's workflow. So we introduced kagent, like a GitOps validation, semantic validation agent that runs as part of the GitOps automation. The agents get invoked by the changes on the pull requests via a GitHub action. And it analyzes, like when a YAML manifest gets pushed, it analyzes the semantic meaning of the manifest using LLM reasoning, renders or simulates rendering of deep dependencies like Helm charts in the manifest, and detects any misconfigurations, anti-patterns, and risks, and report back to the pull request as a pull request review. So you can think of it as a smart reviewer that actually understands the meaning of the YAML manifests. So we will have a live demo to demonstrate all this. Lynn is our developer, and she wants to bring a new application to the cluster.
All right, does anybody wants to see a live demo? Yes? Okay, wish us luck. Especially a demo on a French keyboard. This is the first time I've actually ever done this, so. All right, I'm going to enlarge this a little bit. Okay, can you guys see the font in the back? Is it too small? Yes? Good? Okay, I actually don't know how to change that on a French keyboard. Thank you, Sarah. Is it better? Okay. Okay, so in my GitHub, I have a branch ahead, so I'm going to try to contribute a PR to your repo so I can maybe propose some changes to your cluster, Sarah.
Yeah, please.
So let's go ahead, open the pull request, and let's review the change really quickly. So I want to kind of merge this new application I built, and I kind of want to show you all. So basically, we're using Argo. So I'm building, based on what you told me, Sarah, I'm using Argo, and I create a namespace called music, and I create an app project, and I want to deploy to your cluster. And this is the source of the repository, and I package my application using Helm. And I have a resource quota, and I have an Argo application with the chat app. You can see I'm on the version 5 of the app, and I'm deployed as a service type load balancer. All right, so I'm going to go ahead and create a pull request. So Sarah, maybe you can let me know if there's any issue with my pull request.
Yeah.
All right, I know, go ahead, explain this.
Let me go back to the other. So Lynn is trying to create a new pull request with her changes to the cluster. So at this point, the agent gets invoked by the GitHub action, and it tries to analyze the manifest provided by Lynn and validated against the live cluster, which means that this agent can interact with our cluster and provide some semantic validation to make sure that the application will run and there is no runtime issues. So the analyze will take some time. The main issues we are introducing with the manifest that Lynn tries to sorry, I will make it a bit bigger for you. Yeah. So we have several issues here. The first one is that, sorry, the first.
How is the agent doing? I was hoping.
Yeah,
By the way, this
to
is an interesting scenario because Sarah works with a lot of people like me in her workplace, and she didn't want to repeatedly explain to people problems with their YAML. So she thought of having the agent do the work. Let's see if the agent can do the work.
Exactly.
I guess it did.
Exactly.
So Sarah, let's look at what the agent says.
So the agent finalized the analysis, and it provides a pull request review with the different resources that will be created in this cluster. So the two first resources are defined in the manifest, but the GitOps agent, was able to discover the resources that will be created by the Helm charts itself, the service and the deployment. We don't have these two resources in our manifest. This is a deep dependency that the agent resolved in this scenario. Then the agent is given an impact prediction, like a developer-friendly way to explain what will happen if we merge this specific changes and a risk analysis. So in this section, we are the agent is detecting some issues. Like for example, here we are trying to use some node selectors and toleration that are not valid with our current setup. We don't have the label storage in our nodes. So the agent was able to detect that this will cause a pending scheduling of the pod. We also have this issue with the resource quota limits, because Lynn tried to use more CPU than allowed in her namespace, and the agent was able to detect that this will break the runtime, and the agent was able to predict and the impact and propose a mitigation to solve this issue. So Lynn, can you please fix the issues we have here and try again?
Okay, Sarah, I think the agent did a good job. I feel like even if you don't explain to me, I can understand the risk analysis. So based on what agent says, I'm going to jump onto here. So this is the same GitHub PR. By the way, the reason I jump on here is because this is logging with my identity, so I can actually go in and fix things. That's why we're switching the browser. So what Sarah reviewed with me is also available to me as well and with everybody. So let's do this together as a team. So what I'm going to do is I'm going to, based on the feedback from the agent, we're going to live edit the changes. So we're going to go, you guys can see in the back, right? So I'm going to hit the edit button. Make it a little bit bigger for you, all right? Let's hit the edit button. And all right, so remember the first issue we had was resource quota, right? So I think it says we have a limit of CPU, which is 1 and 2 gig on memory, and our app is asking, wow, that's a lot higher. So all right, let's change to 500, you think might be working? Mm-hmm. And the memory looks good. And I think the other issue the agent report was the node selector, right? So I'm going to go ahead, delete the node selector. I think I probably copied that from one of your applications, that the sample you provided.
Classic
without
issue.
A lot of thinking, right? What else? Is that the other issue the agent reported?
Exactly.
All right, so team, what do you think? Did I miss anything? Yes? Should we merge it? Yes? All right, let's go ahead, commit the change in. And do you think an agent will actually tell me maybe if I'm okay, or are you going to merge it without other feedback? What do you think, Sarah?
It will run again, like the analyze will run again, and can you scroll back? Yeah, it's just running again because you created you pushed a new commit, so this will analyze again the results of your changes and tell you if it is okay to merge it or not.
Okay, so basically this would give you the confidence when you look at my PR, you know, okay, the agent already did the cleaning job, the hardest, boringest work for us, and you will have more confidence when the reports come back from the agent.
Exactly.
All right.
Let's wait for it.
Yeah, does anyone have a quick question while we wait for the agent to do its job?
Yeah, go ahead, please. Still running.
Yeah, still running. The mic is not on, sorry, unless you can yell.
Okay, is that better?
Yes.
Cool. So can the agent go out to the internet and actually find, like, if I'm referencing a specific Helm chart version to install, pick any popular software, and check to see that it matches? You said, like, does a deep analysis into it. Can it check that, or does it have to, that chart exist somewhere in a repository where it can reach it that, like, you're hosting?
You mean in terms of the Helm chart dependencies, or?
Yes.
Yeah, so the agent is pulling the Helm chart and trying to render it and validate it against the live cluster.
Okay.
Which means that you can push your chart anywhere, and the agent will be able to pull it and render it.
Oh, okay, so you don't need to pre-configure anything. It kind of can just go out and pull information from that chart.
Exactly.
Okay, cool.
Yeah.
All right, great question. Looks like we got the feedback from the agent. Thank you for that question. I think, Sarah, it looks okay, maybe the mediate risk?
Yeah, we have.
What do you think?
We still have one single problem here, and the agent was also able to see it, because the secret you are referencing in your image secret does not exist in this cluster, so this will also cause appending.
Okay.
So you need to change it and push again your.
Let me do that quickly. This is a little bit unexpected, but let's do it. Maybe just to save time, do you think there's any other issue? If not, maybe let's save time and merge it. Do you think it's safe?
You try. Yeah, we can merge it if you don't want to let the agents give you the final feedback, because anyway the agent will be happy with this manifest. We don't have any violations or risks, but let's wait for a few seconds to have the final verdict and then merge it.
Yeah, I think we're a little bit short on time, so maybe just merge it. Yeah?
Yeah, if you
All right. Finger crossed. We don't have a lot of time, so we're going to go ahead and merge this. And finger crossed, I can get the demo application deployed. So let's bring up the Argo so we can see how the application is doing.
So in our environment, we have Argo CD running, and it's managing different applications. We have an app of apps that is running inside our cluster and installing other applications. So let's synchronize and wait for the Lens application. As you can see here, the chat app is deploying, and it will take few seconds to get it up and ready.
So I guess what's really nice is you don't have to do anything, right, Sarah? In this case, the agent did a lot of work for you.
Exactly.
You are the final approval for the PR, and then once the PR is merged, Argo automatically sync to the live cluster. You can just maybe drink your coffee on the side.
Exactly. This gives more confidence and reduce the amount of the manual reviews you can do in your organization. So let's wait a bit.
All right, let's see.
Okay, so the application is deploying. Let's wait for the pod. And in the meantime, do you want me to switch back to the?
Maybe we can check if the app is running. We have to wait to the pod, right? So yeah.
Now it's okay.
So should I go to the demo application?
Yeah. This one.
All right. So this is the demo application. Finger crossed it's running. All right. So I thought to do something really special for Sarah because it's her first time speaking. So I want to kind of share some music with her. So Sarah, what's your preferred music while you explain how the agent works? Do you prefer classic music or rock music?
I like classic music.
Classic music? All right. What about the audience? Would you prefer, how many of you prefer classic music?
No one.
Classic? Okay, sounds like classic is pretty loud. How many prefer rock music? Oh wow, Sarah, would you be convinced with rock? Sounds like more people want rock. Let's go with rock, okay? Because the audience wins.
Yes.
All right. All right, so we're going to play rock music.
Yes, sure.
All right, so the music is playing, and we're going to change the music to a background noise. actually maybe lower it a little bit. Sorry, this is a French keyboard. I just can't touch it.
I'm sorry for that.
All right, and then we're going to pass to Sara to explain how the agent actually does its magic, where you all listen to some rock music.
So the agent is defined as a CRD managed by the kagent controller. Kagent creates the pod for our agent, and the agent itself is having access to different tools to interact with the environment. So you can see here that we are using some Kubernetes and Helm tools provided by the tool server from kagent installation. And we are also using the pull request review tool from the GitHub MCP server. And the agent itself is connected to a LLM model for the reasoning, the LLM reasoning. So with this approach, we bring more intelligence to the GitOps validation process, and this helps us to get like early feedback for our developers before the changes hit the cluster, reduce the amount of the reviews we need to do, and helps us enforce some rules and validations across the different teams. So. Combining intelligence agents with declarative workflow, we can make GitOps truly self-healing, self-reviewing, and self-correcting. We are trying to also improve this agent to do more remediation as code and propose the changes to the merge requests in terms of suggestions to implement by the developers, like maybe the next edition of this agent. Thank you, and we'll be happy to take your questions.
We do want to be sure to capture all questions into a microphone so that they make it in the recording. So if you raise your hand, I will come to you. We've also got a microphone in the middle.
Hi. My name is Javier. I work for Bell Canada. I'm a platform engineer as well. One of the questions that I have is, when you were playing with the manifest, with the secret in particular, we saw a message, right? The error message saying, oh, this secret does not exist in this namespace. From my understanding, though, nothing was deployed onto the cluster. So we're just making this assumption from the manifest and kind of predicting, if you deploy this, this is what would happen. So this works well for this use case because it's a YAML manifest. Everything is declared nice and neatly. In our case, we do kind of have some custom homemade Helm charts. So my question is, how would the K-agent know that something is missing if it's like a very complex homemade Helm chart? How can it know that something would break if it's deployed?
Yeah, so if I understand your question here, you are asking if the agent is able to interact with the environment and look for the missing dependencies, right?
Well, yes.
And
Exactly.
also very complex configuration, maybe homemade, that's
Exactly.
not standards, using like Argo Kubernetes resources. Is that? Okay.
Exactly.
Exactly.
So the agent here was able to analyze or understand the meaning of the Argo CD application and render the Helm chart that the application is using. Also, the agent was able to check the configuration of the cluster, the nodes, to tell that the node selector and the toleration that we were using were not valid for this environment. And also for the secrets, it's in this specific demo, we try to have everything in the same manifest for you to understand what we are, and also reduce the switch between the environments and the manifests for like, we don't have a lot of time to demonstrate all this, but the agent is able to interact with the environment and try to resolve all the dependencies that we have in the manifest. So if the agent is detecting a secret, it will run get secrets on the Kubernetes cluster to check if the secret actually exists or not.
Yeah, the other thing I want to add is right now, earlier I talked about the agents are composed of system prompt, which is the instructions, connection to large language model, and tools, right? So the tools you can provide yourself, the connection to the large language model, you could also add your pre-trained data that's specific to your own customer resource, because what we have shown is like the Argo resource, the namespace, the resource quota, which is pretty generic, so the large language model can easily understand and also spot the problems. But if you have specific customer resources, you might need to train the data a little bit more, and also you can add additional MCP server tools to improve the efficiency as well.
So when you define your agent system prompt, you can specify the rules you want to enforce, like, and make the agent check. For us, the biggest issues were like not selects, or this very easy to detect issues. But we have like different, a lot of people suffering with this, like especially developers who they don't understand how the cluster is created. So we wanted to eliminate this first level issues with a very simple agent that detects this kind of misconfigurations. But
by the way, can you make this a little bit bigger? This is actually the agents that's doing the work from the GitHub action. So you can see what's interesting with Kagent is everything is very declarative. The 3 components that's made of your agent, it's all declarative in YAML, and you can represent it very easily, and then share it across your team member, your different cluster as well.
Exactly.
Are we out of time, I think? All right, thank you so much. Enjoy the rest of KubeCon.